there is going to be a presentation followed by plenty of opportunity for questions and a discussion. And it's going to be an hour long, so we're going to really try to finish at 2 on time. Please keep your microphones muted and camera switched off during the presentation. And as mentioned before, the slide deck is going to be made available after the event in a follow-up email to everyone that attended today, as well as there's going to be a clean recording of these and all the other masterclasses in the resource section of the RISE website. And I'm going to provide all the useful links in the chat in a minute. Please do ask questions in the chat function as we go, and there's going to be an opportunity to ask questions directly after the presentation. And then finally, there's going to be a quick poll and a word cloud at the end of the session. If you can please really try to complete them, as they do help us understand the level of knowledge that you've gained in our topic. Without further ado, I'm going to pass it over to Kate. So the recording has started. I'm going to mute myself as well and switch off my camera, but I'm going to be present. If anyone, as mentioned before, has any issue, please do reach out to me. I'm going to try to help. Thank you, Kate.
Thanks, Sophia. Thank you, and welcome everybody. So this session looks at project risks. I mean, it does talk about social housing fund, but if you are running a local grant, I'm sure there are similarities across the programme. So don't worry about that too much. We've got quite a few slides to get through today. So please do write any questions in the chat if there are any as you go through, and we can pick them up at the end. So we're going to have a look at some common risks in retrofit projects, some risk identification, mitigation, and then look at them within the context of managing via PAS 2035. We'll then look at resident engagement risks and some good practices, and finally some resources to help you develop your own programs. So there are some common risks that we need to consider when we're starting a retrofit project. Hopefully some of them are fairly straightforward, but so sort of existing property risks are ones that we need to consider. So particularly any structural issues, they really need to be addressed before any works take place. But also I would say things like damp issues, moisture ingress, that sort of thing, anything that needs time to be resolved before you start your retrofit works really need to be brought forward in the program and not necessarily done at the same time. So an example could be where you've got a gutter that's been leaking over a number of years. It could have made a wall very damp. You actually need that wall to be able to dry out before you do any interventions on the property, particularly if you're looking at insulation into that particular wall or on the outside of those walls. So as you can see on the slide here, you've got some examples of where we might want to consider, particularly around structural, so cracks in walls, hopefully nothing as severe as the one in the picture. Consideration of load-bearing elements, particularly important where you're putting things on onto the weight of the property. So that could be things like system build properties where there might be a timber or metal frame, or potentially impacts on panel designed activity. Potential roof damage, and settling is obviously an issue that we have across a lot of the country, where heavy clay soils dry out and then contract, and then potentially over winter expand again, and it moves, it creates movement in the building. Moisture and damp is a really important element within a building. We are hoping that by doing the retrofit works well, we'll remove issues around moisture and damp. But basically in the UK we have a maritime climate, and one of the things we want to do is one of the things we struggle with is kind of the amount of moisture in the air, the humidity, and we really need to reduce the humidity within a building so that we avoid risks of condensation. That's where the moisture in the air drops out on a cold surface, and then if that happens regularly, that will lead to mold growth. And as we know, it's not great to have mold growth indoors. There are obviously other types of moisture ingress. So you could have a crack in the wall, you could have missing tiles on a slate. We've already talked about rainwater ingress. You could have rising damp or damp coming through a wall where the ground surface level is higher than the damp proof course. So it's really important that we understand what where those issues are coming from so that we can deal with them appropriately. Not all damp, a lot of damp is actually condensation, not all of it, but a lot of it often is. So that brings us on to ventilation. So a lot of our old buildings were built to be quite leaky. So we didn't tend to have as many ventilation problems in the past because windows didn't fit so well. We had open fires, that sort of thing. So we had a lot of ventilation, and it helped expel excess moisture from the building. As over the years, we've made our homes more airtight by putting in double glazing, putting insulation in the walls, etc. We've actually made them more airtight, and for a long while we haven't upgraded them. So you haven't necessarily had to upgrade homes under the building regulations unless you were really making fundamental changes like an extension. So what we've found is a lot of homes still don't have a ventilation extract from all the wet rooms, so kitchens, bathrooms, utility spaces, that sort of thing. And it's really important that we consider this as we go ahead. Ventilation is clearly more important than just doing humidity. It helps remove stale air from the house, so carbon monoxide, carbon dioxide, VOCs, various different things like that. So it's really good for indoor air quality and managing odor issues and that sort of thing. So it's a very important aspect of retrofit. It hasn't always been taken as seriously an important aspect of retrofit, but we will talk about it a lot in our masterclasses because it is very important in that process. And we have a little diagram here about good ventilation design. So in this diagram you can see that there's cold fresh air that's being poured in through probably trickle vents in windows, and then it's being expelled from the wet rooms by an extractor fan to the outside. So that's a sort of simple approach to ensuring good air quality comes in. There are other routes that you can do that. You can have a continuous extract, which is similar to this, but runs all the time and increases when there's a higher moisture level. You could have localized room extract, which will enable, you can also have a heat recovery system. You can have a centralized system, so an MVHR is an example of that. So there's lots of different approaches, and it needs to be designed appropriately for the building and the level of airtightness that we're going to try and achieve through our retrofit approach. We should also consider the number of occupants in the building at the time of the works that taken place. Certainly there is a recommendation of what type of extract you need based on the number of rooms and the number of occupants. This is all really important because it's all part of the considerations around occupant health. As I'm sure all know from the AWAB's law, that excess moisture in a poorly heated home or poorly insulated home, one that can't retain the heat in the walls, will result in mold growth, and that's really not good for our health, particularly when you're young and your lungs are still growing, but also if you have other respiratory illnesses, if you've got heart disease, various different issues around cold and damp and moldy homes that are really not good for our health. And it directly impacts the health service and the number of people going and using the health service. And if we can't resolve it, they come out of hospital and go back into a home that again is not great, and could make their problems come back. So really important that we think about the occupants of our houses and why we're designing them the way we are. Okay, so we'll have a look at some of the risk identification approaches. There's various approaches you can take. So there's a sort of brainstorming. Some people don't like to use that word anymore and prefer to use a thought shower. But anyway, sitting down and thinking about different things that could impact. So as a team, it's a discussion process where we all use our experience and ideas to come through that. Thinking about the root cause analysis. So investigating the underlying causes of those risks. So, when we looked at some of those risks at the beginning around movement and damp and mold, it's really important that we absolutely understand what the risk is. As I said, sometimes damp is considered damp, but actually it's a condensation issue. So we really need to understand what we're treating so that we can treat it appropriately. A SWOT analysis can be useful. It's looking at strengths and weaknesses, opportunities and threats. You might want to do a strengths and weaknesses about different approaches to retrofit and how it could resolve an issue. You can do expert interviews in terms of consulting with appropriate people, experts within the industry, particularly where you may be not sure about particular causes of issues. Thinking about structural issues or particular areas around damp penetration or condensation risks. So really useful to think about the most appropriate route to doing risk identification. We're now going to have a look at some examples of different retrofit approaches and the sort of things that came up under that these different approaches. So the first one we'll look at is retrofit for the future. And anyone that doesn't know about retrofit the future, it was done probably about 15 years ago, I think. And it was funded by Innovate UK as it was then, as about £17 million. And it involved the deep retrofit of 115 houses in 86 projects across the country. The Innovate program required at least 2 years of monitoring, evaluation, and a review of the property to understand how it had performed post retrofit. So that enabled them to learn sort of where things went wrong or what the successes were. And last year there was a report published in 2024 that was a 10-year review report since the completion of the programme. So in this review, they revisited 10 homes that were considered exemplars or best practice at the time, and they did an analysis on how they'd been performing 10 years later. And I think it's a really interesting report to have a dip into. They delivered most of the retrofits delivered a long-term savings, so there wasn't a deterioration in performance. They found that the weak points in fabric improvements were around windows and doors, and we'll come on to that a little bit later. Moisture and condensation was generally quite good. Indoor air quality was generally quite good across most homes. But the theme that came out mostly on that was maintenance of the systems. So ventilation systems was really important for gaining that long-term success. So it's really important that when we're thinking about improving all our properties, we've factored into our longer-term maintenance structure what it is we're going to do to make sure things work well. Other things that came out is around the complexity of systems. So most of the homes in that program had gas boilers, didn't have air source heat pumps. So we need to think about how we're installing different systems and how we're supporting people. And the MVHR systems that were installed did work well, but again, that comes back to the maintenance, changing filters on a regular basis. Some other notable things that came out of that, and I think are important for us to consider because this is another risk, is around overheating. So when these projects were undertaken, the overheating risk wasn't as well known as it is now. So they do have some overheating issues in the properties, but no worse than a benchmark. So obviously there's been a lot of work on overheating risks since that, and it's worth considering when you're doing retrofits as well, that we don't want to add to the potential for overheating. So the next program to look at is ECO, and there have been a number of quite bad situations that have been aligned to ECO. So in Glasgow, some external wall insulation fell off the top story of a residential tower. You do not want to be underneath that when it comes off. It's pretty dangerous. So the failure was clearly something to do with the fixing mechanism. I don't know the details on that one, but you know it's not what you need when that sort of thing happens. You may remember that the outer leaf of a wall on a school fell off as well, so that was obviously a construction detail and something to do with probably wind loadings, so it's really important that we consider that. Won't go into Grenfell Tower. I think we all know what happened there, And then there have been other numerous failures around cavity wall installations, and particularly external wall insulation. I suspect there's a whole bunch of internal wall installations that haven't been detected yet, but could be uncovered in the coming years. So it you know, retrofit is complex. There are risks. It's really important that we understand what the risks are before we start doing it. Not that it should put anybody off, but if we don't understand the risks, we're going into things with our eyes shut rather than with our eyes open. And we can put risk mitigations in place, or at least monitoring systems, so that we can understand what we need to look at and when. So the next on our list is the Renew program, and that was a GLA run program. The learning out of this was really to think about considerations of risk. So in the picture here we have a risk matrix, and some of you might have seen this in some of our PAS 2035 sessions. The same people that worked on this probably worked on the development of the PAS activity, and this identifies areas where you've got greater risk. So where you've got a 3, it's a higher risk, and we've got compatibility issues and non-compatibility issues. So it's really helped to identify where things can go together, but also the increased risk of putting certain elements together next to each other. So I think got MVHR here. I don't actually know what the scoring mechanism is, so probably shouldn't talk about it more than that. Okay. We then got the Centre of Refurbishment Excellence, and anybody that will know that, that's CORE, and CORE became the Retrofit Academy, or it sort of wasn't maybe quite as seamless as that, but certainly out of CORE, the Retrofit Academy did rise like a phoenix. So I think a lot of learning taken place there. So it was an EU funded project. There was a lot of work on the process of retrofit, so looking at those boxes at the top: assessment, design, installation and operation. So it looked at potentially conceiving the idea of a retrofit coordinator, so looking after the whole process, taking responsibility of the retrofit installation from beginning to end. And it's really important to remember that out of that comes the kind of engagement with residents, and we will get onto residents as a risk at a later stage in this session. But we really need to understand, yes, there are technical risks for sure, but there are also risks around how we deliver that, and the people that live in those homes, and how we work with them as well. Next is the Sustainable Traditional Buildings Alliance and the STBA wheel, sorry, and this is a really it's a really good tool. It's got a lot of references in it. It's very, very detailed, and it's probably a more complex version of the one we looked at under the Renew program. So it's trying to identify areas where, if you do a type of wall insulation, what are the impacts in these different areas? So roof, floor, windows, doors, chimney, etc. And then it will, if you were on the wall, you could click on one of these and it would come up with a risk, and it will probably give you a reference to a document where you could go and have a look at and past experience and the outcomes of that property. So it's a really, really useful tool, but it if you're not an expert in some of these areas, it could be a bit it's quite a lot of information to take on board, but a really useful resource. And then out of all of this is the UK Centre for Moisture in Buildings. It's probably getting on for about 10 or 15 years old, I think, as a sort of centre for excellence. And they've been really influential in driving the progress towards improvement in ventilation in retrofit and consideration of other things. Certainly I've worked with them and the STBA to develop some tools around thinking about moisture and condensation within a building, and they have a lot of really useful detailed scientific research. So again, if you really wanted to look into that, it's a really good place to have a look for more information. Okay, let's have a look at some risk mitigations. So we're going to just work through the kind of 4-part process, which is thinking about risk assessment, design, installation, and operation. So some of the risks that come up: you have the wrong assessor. So what's the wrong assessor? Somebody perhaps that isn't skilled enough for the type of property, perhaps doesn't have the right qualifications, perhaps doesn't have any qualifications to do the assessment. So it's really important that we start with the right people and to get a really good outcome from the beginning. Inaccuracies in assessment. There are so many assessments out there that are inaccurate with wrong wall types, saying that it's got gas heating because it's got a single gas point heater and no other heating in the house, or everything else is electric. So there's always lots of things that you could do a sense check on with any EPC data. It's getting better over the years, but there are some of the older ones in particular are quite poor. Consideration of incorrect measures. Well, if you say it's a cavity wall home, and you would be then saying that cavity wall might be a good solution for that property, but it could be that it's a solid or timber frame construction, and therefore cavity wall would probably not be an appropriate measure for that building. So you're then kind of giving people wrong expectations about what they can do. And there has been optimistic outcomes around fuel savings. Some of that is built into the software that it's using, so it's looking at sort of the proxies that are built into RDSAP. So we can think about that in terms of mitigation. So we can think about the qualifications that we need people to have, the training that we need them to have, whether they've had experience on particular housing types. So we can ask them those sorts of questions. We can, when we do our procurement, that's something we can consider. We might want to triage the assessments through somebody that's more senior, that can double check them, do a quality assurance element of it. And it's worth us doing our own checks for sort of sanity point of view, particularly if you have assets that quite well. You might want to just check the EPCs that come back to make sure that they reflect the properties that that they're talking about. Assessment software, it could be that somebody's using the wrong assessment software or they've not updated it, so that's really important. And we need to know what the occupancy is on these buildings, because you're not going to get the same output with one person compared to 5 people living in the house. You can probably have a lower heating threshold with 5 people, because you've got 5 people generating heat as well, rather than just one. So it's really useful to have a sense check on all of those things. At the design stage, is probably a really important stage when we think about it. So firstly, you want to have the right strategy for that building and for the outcomes that you're looking for. So assessments are a key to that, having the right information to start with, but you want to have a good approach to your strategy. So if you have a gas heated home and you want to put in solar PV, and you've got a gas heated home and somebody's out at work all day, but you want to put in solar PV and battery storage to get into an EPCC, great, you will get the EPCC, but you probably will not make that much of a dent in their energy bills, and no difference to the heating and comfort in that housing if you've not done any other improvements on the property. So it's possibly not the best strategy. It might achieve an outcome that is what you're looking for, but it won't achieve as many outcomes as you could do. Integration of measures, we thought about that a little bit already, how they work together. So the guidance is really around where measures come up against each other in different planes. So floors and walls, walls and walls, walls and windows and doors, walls and ceilings, and walls and surfaces. These are where we have issues generally with measures not working. So it's really important that we think about strategy around that, and how we can mitigate against it. So it is things like saying to your plumber, when you put a new hole through the wall and you put a pipe through there, I want you to seal it, and I want it to be a good seal, so that you get you're not getting heat loss out through that hole in the wall, and you're not getting unnecessary air ingress in as well. Overheating, we talked a little bit about that. It's really important that we consider overheating. There's a UK maps around what future climate scenarios are going to be. So there was something out earlier this year. I think the west of the country is due to have wetter winters and summers, with heavier periods of downfall, rain. So that's not necessarily it's wetter more days, but it could be that we just have heavier rainfall more often. in the southeast and a lot of the east of the country, similarly, could be heavier winter downpours, but actually less in the summer. So sort of drier, more drought conditions. So also in the southeast, there are maps that indicate sort of risks from overheating as well. And actually, most of the southeast comes into that, whether you're rural or in a city, but certainly within a city or town where you've got more hard surfaces, more concrete, that's sort of absorbing and reflecting heat during the day, there is actually more risk of that heat accumulation in those locations. Again, if you're higher up in a building, heat rises, you're more likely to get that heat accumulating. So it's really important that we think about things like purge ventilation, what's the other one? Shading opportunities. Sorry, I got there eventually, and extract ventilation, so that we can think about how we can manage sort of heat build up during the day in buildings. So design is incredibly important as we move along in this process. Installation. I mean, design is one thing. This is how we go. This is what we want it to do, and this is what the outcome should be. But installation is the important factor. So if we don't do the work the way it's designed, or we do that work poorly, then the outcomes are not going to be as designed. So some of the things around integrating of teams, so different teams from different subcontractors potentially working on properties at the same time or in not necessarily sequential order, not understanding what the other people are doing, not necessarily talking to each other, maybe not always respecting each other. So it's really important that we bring people together and explain how something has been designed. With passive houseworks, there's normally somebody that's an air tightness specialist on the team that's responsible for making sure everybody who works on that property understands the air tightness issues and what they're trying to achieve as a passive house. So it could be similar, even though we don't have the same strictness around passive house and certification, taking an approach where we think about who's responsible for the quality on the building site, and especially when we're working with multiple teams, could be a solution that we look at. Substitution. This shouldn't actually take place, and it really shouldn't take place without the approval of the retrofit coordinator. So one of the roles of the retrofit coordinator is to approve any substitutions in the design materials or design approach by the contractor. And if it doesn't get approval, then it's not compliant to the original design. So it's worth really noting that, and it's worth making that something that you discuss with your contractor, because they are liable for any changes if it's not followed that design approach. Poor installer design. Sometimes we don't go through a designer as such in terms of an architect or somebody like that. So it could be that sometimes the installer hasn't really necessarily understood the nuances of the building type, or has maybe not the experience to work on that property type. So it's really important we think about who is designing what and what are the risks that go alongside that. So it's not to say an installer is not the right person to do the design. We need to think about the building, the type of building, their experience, whether it's interacting with lots of different other things that we're doing on that building. And then also commissioning is really important. If we don't set thermostats, if we don't set the temperature to come on right, thinking about moving from gas perhaps onto a heat pump, you used to maybe having your gas on at certain times during the day to sort of heat up the home while you're there. With a heat pump, you want to have it on low all day so that you've got this residual heat, and that takes quite a lot of it needs to be commissioned so it works that way, but it also needs to be worked with the client. So hopefully on the next slide, in operation. So we need to think about that handover procedure. So what have we done and why? And what does the client, the occupant, need to know in terms of how they use the building differently from how they've been using it up until now? And that can be a very big challenge for a lot of people, particularly if they're older and they've lived in the house for a long time and they've had the same sort of systems. They've got completely used to doing something. So that'll be a massive change for them. And they may not be up to speed with some of the digital elements of new installations. So it's really, really important that we consider all of this as at the time of design, but take those customers through that process. Excuse me. Controls are incredibly important. You know, we talked about setting controls for the right time zones and to come on and off at the right times, but also choosing the type of controls that you put in is also a really useful approach to take. Now, I'm going to use me as an example. When I first moved into my flat, I had a really good control system, temperature control, timer control. It did lots of different I didn't do zones. I've only got a small flat, but it did lots of different kind of days that you can, and 6 different settings in the day. It was fantastic. But the buttons on it were so tiny. I used to have to try and get a pen out to use it, and it became so infuriating. I changed it. And what I ended up getting put in, and I'm not sure if it was my mistake or the installer's, has less flexibility around how it's timed, so I can't do a weekend separate to a week. It's exactly the same, which frustrates me enormously, but the buttons are really big and I can use them and it's really easy to work through. So we really do need to think about, you know, what are we giving to people? How easy is it to use? How much control do they have over it? Or is it something that's just not going to be used properly, and they either will mean their costs are really high or they don't use their heating, and that's not what we want people to do. We want to test performance afterwards. So ideally, you know, this is where we do monitoring and evaluation, but also going back and speaking to residents and understanding what is your experience of using this? Can we help you again? You know, particularly if you're putting in new heating systems over the summer, the non-heating system, what have you got in place for when somebody wants to put their heating on in September or October and suddenly realizes, oh, I don't know how to use this because it got installed in May and I haven't had it on all summer. So, you know, those sorts of things we really need to consider as kind of risks within our project around the performance and getting the outcomes that we want. Okay, let's have a little look at sort of risk management in PAS. So hopefully all of you are very aware of PAS. It's a process that is there to support the installation, the correct installation of retrofit measures. The retrofit coordinator is the key role within that, and they are responsible to the client and to the public. So that is a really important element. But one of the things that we need to, it's useful to think about within the PAS is around the 4 C's. So they are context, coherence, capacity, and caution. So we need to think about the geographical location. You know, is it right by the sea? Is it wind-driven rain? Is it on the east of the country? Are we going to have overheating risks? What's the context there? We need to think about the legal context in terms of the type of installations that we might do, what grant funding we might be using, the ownership of the property, various different approaches there. And we might need to think about some of those things like cultural differences on how people live in their homes and use the homes differently. So coherence is looking at kind of a really consistent approach to the thermal performance of the property. So what we want to try and avoid is any particular cold spots where any excess moisture in the air could condense and cause issues to air quality over time. So that's what we're looking for on that one, and you know, we bring in there the ventilation and the air quality issues as well. We need to think about the capacity, so we need to consider the size of the building and the things that we're going to do to that building to make it more energy efficient, and then like the building services that we put in, so that's heating and ventilation extract, in order to optimize. So if you go straight to a new heating system without upgrading the thermal envelope of the building, and you come back later to do improvements to the thermal envelope, what's going to have happened is that the heating system will have been designed for the building being improved, and then you do the improvements, and then it's actually oversized, so it's likely to cycle through and not work at its optimal, the way it should work optimally, could potentially lead to more overheating risks as well. So it's really important that we consider those things, and that's why the fabric first approach is still really a valid approach, even though, you know, getting to EPC is a big driver and doing it cost effectively, and moving on to heat pumps is one of those ways you can get there. Understanding the theory of the fabric first is really important to help you determine whether that is still the best approach. Caution. So there's still a lot we don't know. You know, we're finding out things all of the time. So, you know, understanding the risks, and the greater the risk, you know, the more caution that we need to exert onto that. We need to identify, assess, and mitigate risks, and we need to sort of avoid ones that we really can avoid, ones where we don't know what the outcome will be, preferably, and fall back to those trusted approaches. I'm not going to go into this in too much detail, but this is sort of an expanded version of the one we looked at under the Renew program. Really details out what the risks are, etc. So resident engagement, we've talked about this a little bit already. So I'll kind of whiz through this as quickly as I can because there's quite a few slides. So we want to reduce the risks to residents through our design process, but we really also need to think about the residents that are going to use the building, and think about how we can reduce the risks around resident behaviour, resident use, that side of things. So this is why resident engagement is so crucial for driving success in retrofit, and particularly where we're bringing in unknown or untested technologies. So we talk about heat pumps here, but there are other technologies where, or approaches that could be similar in that. I mean, I think ventilation is probably one that people have experienced over delivering under the recent Hug 2 and Wave 2.1, 2.2 programs. I think engaging, consulting with residents, taking them on a journey helps bring them along with you, and it helps them ask questions, because we don't all have questions. I suspect not everybody on this call is going to ask me a question at the end of this, but maybe you can surprise me. We won't all have questions while we're in the moment. We'll need to go away and think about them. They might not be something we think about instantly. You might be doing something one day and think, oh, I wonder if that's going to be impacted by this thing that's going to take place. So the earlier we can engage with people and take them on a journey, the better buy-in we're going to get, and probably the better outcomes we're going to have. And people can raise their concerns, and we can try and find solutions to allay those concerns, or identify how we can remove those concerns. It may be that they've got a really valid point we haven't thought about, and we have to go away and think about it, and work out solutions taking it forward. It's useful for that feedback loop, so we can learn ourselves about what works, what doesn't, what could be improved. And we really need to understand how it fits within a compliance and safety side of things. So monitoring and evaluating performance of retrofit property is really important to making sure it's working the way we want it to, but we're also not getting further unintended consequences. So, you know, again, we're trying to eliminate excess moisture in a house to, you know, comply with that Awab's law. You know, we could do loads of stuff and end up finding out we're still getting too much moisture in the building. So what do we do about it? So as I said, engaging residents early in the project life cycle is essential for taking people along that journey, particularly around heat pump technology. Education and awareness. So where you may have done a trial, it's really helpful if there's opportunities for people to learn from that resident, whether they could possibly come and do some presentations, or be used as a case study, or be filmed being asked questions, demonstrating how that system works, the impact on them, things that they've worked out that they don't like, or that have had to change the way they live, can be as useful as things where they're just talking about everything that's a benefit. So I think we all learn much better in many respects from other people's mistakes, because that's what we want to try and avoid ourselves as we move forward. There was a really great podcast I listened to a few weeks ago on the Zero Ambitions podcast, where a woman had a heat pump, and again she hadn't had it set up and optimized properly. So they managed to get somebody back to do that, and they were getting a much better output. But it's really worth listening to and hearing it in their own words. We want to enhance user experience. So we want to make it easy to adopt new technologies, and we want a good outcome. So again, we've talked about this quite a lot, monitoring and evaluation to see whether it is working. Sometimes things just don't work as they're planned to, especially if you are using some sort of innovative technologies. And I've worked on a project where we were putting in a new innovative heat pump, and it didn't work, and eventually, unfortunately, we had to remove that and put something else in. So, you know, monitoring that, making sure that we're getting the outcome. Actually, you know, the residents in those properties had extremely high bills, and they were all panicking about the cost, and we were doing sort of whole house retrofits. So you know, there were issues. If we hadn't been monitoring that, these residents would either have had extremely high bills, or they'd been turning their heating off, and you know, they did need some heating even though we had improved their properties. We want them to use their new systems or houses, the changes. I'm going to use the word correctly. I don't like that word, because what is correct for one person may not be 100% correct for somebody else, but we want to optimize how that system can work for them, for their circumstances, and that they feel comfortable with that. And, you know, if we can do that, we will get better satisfaction out of it. And we'll get better satisfaction if somebody knows what they're doing, knows how to set it, it can reach the temperatures that they want, and hopefully it's either no more than they were paying on a former kind of heating approach, or it's less, ideally it's less money than they were previously paying. Having a feedback loop can help with residents. So having that opportunity, as I've said, if you put in something in outside of a heating season, you might want to go back when the heating season starts to sort of remind those people about the handover process they had 4 or 5 months ago, see if they need somebody to pop in and see how the system is working. You know, it's really important that we understand what's going on, we listen to people, and we take action from that. And hopefully what we get is really positive outcome when it does work. And when we get positive outcome, that leads to greater benefits at a later date. And we've talked about this again a little bit already, but compliance and safety is incredibly important, that we meet all the health and safety requirements. You know, any poor performance doesn't work well for the industry. It doesn't help achieve the better outcomes that we're looking for. I mean, I think pretty much everybody would want a warmer home, one that's cheaper to heat, one that's more comfortable to live in, one that makes their living conditions healthier, and probably one that puts less pressure on to the health service. I think if you went and asked most people in England, Scotland, Wales, Northern Ireland, if that was their preference, they'd probably say yes. So, you know, looking for making sure that we're doing it compliantly, so that we're not having those horror stories come back, and making it more difficult and giving that resistance back into the market is really, really important. So, you know, making sure that we understand what compliance means, having a quality assurance process in place, making sure we've got the correct warranties, you know, maintenance structures, so that we're not actually going outside of our warranties. So when something goes wrong, we go, oh, we didn't maintain it every 12 months like they said they did, so therefore our warranty doesn't work. You know, we need to really think about how we factor those things in, so that we're getting the best out of it, and sharing where appropriate with the residents, so that they are also aware of all of those things. So some ideas around how we can improve those: training resident liaison officers for outreach and support, you know, really kind of digging down, asking residents to do an annual check-in. So what's their energy usage? How are they feeling? Is it working? You know, listening to what they've got to say, and then taking that away and learning from it, and trying to instigate changes. And then sort of budget monitoring and evaluation, or evaluation ideas into your projects right at the get-go, so that we do it and we know what the outcome is, and we're not looking for an available budget to try and make it happen. I'm aware of time and want to finish, so I'm not going to go through this, but we've got some really great examples of peer examples on our website, and we do peer sessions quite regularly, either on our podcast or as masterclasses. So do have a look. And then we've got these resources on our website, and we've got upcoming live events. So there's all these opportunities to get in touch with us as well. So please do consider reaching out to RISE if you are a grant recipient and you haven't spoken to us yet. Do get in touch, because we can provide you with support to help you identify risk and minimize risk in your project, and provide that support to help things go along better. So I think that's probably it. There is one here about a mobilisation confidence assessment. So I better talk about that, because that is quite crucial to this. So this is for all social housing fund grant recipients. We would really love you to book in a mobilisation confidence assessment. So that's looking at where you are now in your mobilisation journey, and how you get to that point for delivery, and seeing how we can support you to get to that point on time or quicker, or reducing the risks, or helping you with a better approach if it's necessary. So do reach out via the RISE inbox if you haven't been contacted already, and we will get in touch with you. I think these slides are going to go out anyway, so you'll have more of these things. But thank you very much. I'm going to finish there and give you an opportunity to speak or ask a question.